So I want to talk about summation. So when we want to sum up things, right? So sum means addition. Um, if we have a lot of things to add up, we typically use this new summation notation, so also called sigma notation. So sigma is because we use this symbol here, right? This kind of angular thing. This is a capital sigma from the Greek alphabet. Okay, and what that means is sum up, add up. So the way we use it, so here I have 1 plus 2 plus 3 plus 4 plus 5, right? The way we write that in sigma notation, so we do the summation, and then we have this, this dummy variable or this index, right? I, and sometimes, right, that'll get replaced with something subscripted, so don't worry, just take a breath. So this says, add up all the i's as I goes from, and then down below we say I starts at 1 and ends at 5. So this is where you start. And then this is where you end. And it doesn't have to be an I, right? Some books use K's or J's. Typically it's those, but it can be other things as well. Okay, so let's just practice. We're getting familiar. So let's go ahead and write this first series with summation and sigma notation. So this equals something. So we're going to write our summation. And let's go ahead and we'll use i's and decide where I starts and where I ends. And then how do I get to look at this? I don't write the pluses, but I need something that's going to describe what each of these is. Okay, so it's kind of like you're looking at the pattern and thinking, how would I describe that pattern to somebody else? Saying, well, these are all fractions. So if you write that first one as a fraction, right? So 1 over 1. Do you guys see it now? All right, so that's 1 over I, make your i's and 1's different, if I starts at 1 and ends at 6. Now, it does not have to start at 1. You can actually start at someplace else if you would like. Then you would just change what this, right, your general term, we might call it, your general term would look like. Okay, let's look at our next one. So again, I'm adding up and write the dot, dot, dots. The ellipsis in the middle says I'm not going to write all of those things in between. So 1 plus 4 plus 9 plus 16 plus, and one way you can start to think about the pattern, it's like, what am I going to write for that generic term, that general term here? And by the way, that general term I should have said, sometimes we'll talk about this as your a sub ith term, right? So a sub I, this is your general term. Okay. What would that a sub I be on our next one? And a way you can think about it is like, well, what would my next term be if I wrote it? So plus 16 plus, what would go in the middle? Or after 121, what would come next if I had to come up with the next one? That's one way that I find helpful for deciding what the pattern is. It's like, oh, how did I get from one to the next? So this one, right, I'm sure you've all decided by now, right? Our a sub I term would be I squared if we start at 1 and we go to 11. Cool. Okay, so some common sums, and C is going to be a real number. N is a positive integer. Okay, so as we're counting, this counter variable is going to be an integer and positive for us. Okay, so if we add up all of the constants from 1 to n, that is equal to C times n. So here's our first one. Sorry, do a numeric example for all these. So I equals 1 to 7 of the number 5. So what that means is, and I'm going to be, right, so this means 5, right, in this counter. If anybody does some computer programming, and I don't even know if this is how it works anymore. Back in the olden days when computers were new, right, you have this loop. So, right, you're just counting through. So 5 for I equals 1, plus 5 for I equals 2, plus I equals 3, I equals 4, I equals 5, I equals 6, I equals 7. Right, so I'm adding up 5 7 times, right? And so a repeated addition is multiplication. So 35. Okay, so that one makes sense. This next one, so if we're adding up all of the i's from 1 to n, we can find that number without actually doing the addition using this formula. It's n times n plus 1, all divided by 2. Okay, so if we're adding up all of the i's from 1 to 10, so I'm going to write out a few. So 1 plus 2 plus 3 plus, all those ones in the middle, plus 9 plus 10 equals. So my formula says that equals n, which is 10, times n plus 1, so that would be 11, all over 2. So that is 55. Okay, now you guys might have had a teacher show you this in right, some other life. It's if you do the grouping, so 1 plus 10, that's 11. 2 plus 9, that's 11. 3 plus 8, that's 11. Right, so all of those sums are 11, and you have 10 over 2, or 5 of them. 5 of those sums of 11. Cool, right? Okay, next one. Sum of the I squareds equals n times n plus 1 times n plus 2, all divided by 6. I'm going to look something up because I think I'm missing a number. I'm glad I did, and I was. It is 2n plus 1. Make sure I get it right before I write. N times n plus 1 times, I don't know where I was looking, 2n plus 1 all over 6. Thank you so much for letting me know. You got everybody who was shouting out at me. So if we're going to sum up all of the I squareds from 1 to 6, so that would be, right, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. And we could just add all of those up. That might actually be faster when it's just 6. But imagine if it was 25 or something like that. You wouldn't want to write all of those out and add them up. So instead, we can do our little formula here. So that's going to be equal to n, which is 6, times n plus 1, which is 7, times 2n plus 1. So what's that? 12 plus 1 is 13, all over 6. Okay, so do that, 2191. Cool. Finally, I'm going to check my last formula. Okay, that one's okay. Make sure you make that correction there. I wrote that down wrong. Okay, so adding up all of the I cubed from 1 to n, that's equal to n squared times n plus 1 squared all over 4. Here we go. Summing up the I cubes from 1 to 4. So again, writing it out. So it's 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. Okay, so what is that going to be? It's going to be 4 squared, so 16, times 5 squared, 25, all over 4. Cool. Reduce, multiply, 100 it looks like. Okay, a couple more rules. If you multiply, here we go, constant multiple rule. So if you're adding up a constant multiple times a sub I, right, that general term has a constant multiple in front, we can move that constant multiple out in front and get the same result. Okay, so if you were adding up 7i as I goes from 1 to 20, we could move the 7 out in front, add from 1 to 20 just the i's, and then use our formula that we have for that. Okay? And then multiply that final answer by 7. Okay. Sum and difference rule. So if we add a sub I plus b sub I, plus or minus, right, doesn't matter. As long as the limits are the same, right, where you start and where you stop, you can do those individually. So that if I had, right, the sum of I plus I squared as I goes from 1 to 5, I can do that separately. I from 1 to 5 plus the sum of the I squareds from 1 to 5. Okay. And then finally, you can split it apart. So if m is between 1 and n, so if m is in the middle, you can sum up the first m terms, get that, and then start at the next term, so m plus 1, and finish off, right, and add those together, right, which makes sense, right, summing, right, if you start at the next one and keep going and then put them together at the end. Oh, look, it was a 7. I guess I was in a 7 frame of mind for these. Okay, so put these two together. Let's evaluate some sums. So we're going to add 7 times I from 1 to 10. So move the 7 out in front. I is going to go from 1 to 10 of I, right? And the formula for that says, so the 7's out in front, and then summing up our i's, we get, right, n so that's 7, times n plus 1, so that's 8. So 7 times, 10, sorry, 10. You guys got me. 10 times 10 plus 1 is 11, divided by 2. So 55 times 7. So that's 7 out in front. So 7 times 55. Sorry about that. What do we get? 35, carry the 3, 35, 30, 85. Okay, that's an 8. Next one. So 1 to 12. So you almost always you start at 1, but you really should actually look at it. So this does start at 1. 1 to 12. 2i squared minus 3. So we're going to split it apart. Move your 2 out in front. I equals 1 to 12 of an I squared minus the sum of 3 from 1 to 12. Okay, so the sum of the I squareds from 1 to 12. So our I squared, so I get 12n times n plus 1, 13, times 2n plus 1, so 24, 25, all divided by 6. Still with me? And then there's the 2 out in front. Okay. And then if you sum up a constant, right, it's just the constant times n, so that'll be a minus 36. Sorry, it's kind of getting scrunched right there. What do I get? Take the 2 from the 6, get the 3, take the 3 into the 12, get a 4. I get 100. I get 1,300 minus 36. You guys check my math. Okay, so I did that one in my head, but I'm going to let my calculator subtract for me. And I get 1,300 minus 36. I'm not sure if that shows up. I know calculator and my camera don't always get along. Okay, so 1264 is what I got. I'm willing to be wrong on that, but I think this looks pretty good. Okay, last one. So here, notice I'm not starting at 1. That was my hint from before. So I'm adding up with the I cubes from 3 to 8. So the way that we would do that is we would add them all up. So think about that last rule, right? We're going to add up all of the I cubes from 1 to 8. Oh, 8, not infinity, Angela. From 1 to 8, and then we'll subtract off those few at the beginning that I didn't need, right? And I don't need 1, and I don't need 2. Okay, I do want 3, right? 3's in this last one. So this one, maybe it'd be faster just to write it, just to find those 2. I think I will. I'll just find these 2 at the end and take them off. Okay? Are you guys okay with that? So if you think about that, so the sum from 1 to 8 of the I cubes is equal to the sum from 1 to 2 of the I cubes plus the sum of the I cubes from 3 to 8. Well, from 3 to 8, this is the part I want. So if I subtract this other term right over to the left, that'll give me the part I want. So if I add them all up from 1 to 8, take off the ones from 1 to 2, that should give me just the part that I want. Okay, so let's find the ones 1 to 8. So 1 to 8 of I cubed, so that's n squared, times n plus 1, so n is 8, n plus 1 is 9, 9 squared is 81, divided by 4. So this is, right, the I cubed from 1 to 8. So for that, we get 16 times 81. So 1296. But then we're going to subtract 1 cubed plus 2 cubed. So 1 plus 8. So we're just going to take away 9. So without having to actually do the big formula, it's easier because I just had the 2 that I had to take away. So, I'm sorry. There we go. 1287. So that's how we use summation.